Welcome to today's lesson. In today's lesson, we'll be taking the paper 2 for our checkpoint revision and past papers. This paper 2 will be focusing on the chemistry component of the sample paper 2, which is based on the Cambridge Lower Secondary Sample Test for used with the new curriculum, which was published in 2020. The first question that we have here is talking about water molecule, and we have to state the type of bonding in water molecule. Now, we have a way to identify types of bonding quickly, especially for ionic and covalent. If I'm having bonding, I have to look at what are the elements that are combined. For instance, in this case, I have hydrogen and I have oxygen. Now, I will now look at hydrogen. Is it a metal or a non-metal? So hydrogen is a non-metal. Hydrogen is a non-metal. What of oxygen? Is a non-metal as well. So you can check your periodic table for that. Is a non-metal as well. So if I have this, any bonding that occur between two non-metals is a covalent bond. Covalent bond. Okay. However, if it were to be between metals and a non-metal, okay? If I have another question next time that is between metals and a non-metal, then definitely this will represent ionic. It will represent ionic bonding. In ionic bonding involves transfer of electrons. It involves transfer of electrons. But covalent bonding involves sharing of electrons. So when we say sharing, hydrogen and oxygen are sharing electrons. Okay, here as well, you can see hydrogen and oxygen sharing a pair of electrons. Okay, so they say explain how I tell, like being asked to describe. So I cannot say it's between non-metal and non-metal. No, that is just used for identification. But the most common way to describe it is that it involves, okay, it involves sharing of pair of electrons. It involves sharing of pair of electrons. So sharing of pair of electrons, that's what it involves. Now, an oxygen atom has an electron structure 2,6. To which group of the periodic table does oxygen belong? To which group? All right, you have been given the atomic structure, and so that makes the work easier. So if it is 2,6, remember, this is called electron in the outer shell, or you say valence shell electron. Okay, valence or outer shell electron. So the number of electrons in the outer shell determines the group. It determines the group. Why the number of shells? If I'm to draw this, I'm going to say, okay, first shell can take 2, second shell has 6. That's the interpretation. So it therefore means that the number of electrons in the outer shell is 6. That determines the group. But number of shells, okay, determines the period. Number of shells determines the period. And so I can say that oxygen belongs to, group 6. Another way to do that is to just simply check your periodic table. So I can check my periodic table, okay? The horizontal line is a period. So this is period 1. Okay, but for group, it is vertical. Okay? So this is group 1, 2, group 3, group 4, group 5. So if I look at oxygen, this is oxygen here. So if I trace it up, that is group 6. Group 6, but it's in period 2. Most often, students get to ignore that of hydrogen and helium, they pick their period 1 from lithium. No, this is period 2. Okay. All right. Now let's take a look at this question. We are to calculate the density of a substance. We want to calculate the density of a substance A. You have been given the mass and the volume, so that makes our work very easy. All right. Density is mass over volume. Is mass over volume. So therefore, I'll just put the mass, which is 90, over the volume, which is 20. Now, I'm doing this directly because the unit is in gram per centimeter cube. So there's no need for me to convert units. This is grams, this is a centimeter cube. And so I can just divide basically and have 4.5 grams per centimeter cube, 4.5 grams per centimeter cube. The next question is, suggest which substance A, B, or C is a gas. Remember, we solved this to be 4.5. So now we want to know which one is a gas. For us to do this, we need to understand the particle theory. What does it talk about a gas? Gas particles are like this, they are further apart from each other. So if they are further apart from each other, we expect that they are the least dense. They are the least dense, okay, when it comes to solid, liquid, and gas. So we just look at which one is the least dense, okay, and that is 0.003, because particles are further apart from each other. So density has to do with how closely packed, okay, how closely packed. That's why it's mass over volume. So the least dense here, the one with the lowest density, and why? It has the lower density. It has the lowest density. Okay. Now, Perry investigate the reaction between zinc, lumps of zinc, and dilute hydrochloric acid. So he's trying to find the reaction is faster. If he hits the dilute hydrochloric acid, he finds that the reaction is faster. So he will now wants to use, we are to use particle theory to explain. We are to use particle theory to explain, okay, why it's faster when it hits the dilute hydrochloric acid. Now, anytime there is a heat, that means there is increase in temperature. Okay, what happens? Increase in temperature, okay, increase in temperature always lead to, increase in kinetic energy. If there is increase in kinetic energy, then that will also increase how particles move. So movement of particles will also increase. Okay, movement will increase. So if I'm going to use particle model to explain this, so I can pick it from there, that particles will have more energy, because I think particles have more energy or more kinetic than specific particles have. If they have more energy, then what happens? Okay, so they will move faster, because you can say move, increase, kinetic energy increase when you increase temperature. So particles have more energy, okay, then they will move what? Faster. They will move faster. So if they move faster, then what happens? So there will be more collision. There will be more particles will then collide with one another, faster than before. There will be more collisions. So that is simply using kinetic theory to explain this. Now, the next question is, he wants to now make the reaction go faster, but he does not want to change the volume. He does not want to change the temperature. He does not want to change the mass. What other things? This question is just asking, what are the factors that can increase the rate of reaction? Okay, we know that temperature can increase, but it does not want to change temperature any longer. Okay, so the only other thing we are left with here is concentration. So we can change the concentration. Okay, we can change the concentration. Okay, higher concentration. Okay, higher concentration of acid. Higher concentration of acid. Okay, if I increase the concentration, then it therefore means there'll be more particles of the acid present, and then there will be faster reaction because there'll be more collision. Another thing I can do, either of this, is that I know that nature of reactants can also increase the rate of reaction by increasing the surface area. That's what I can do. Increase surface area, increase surface area, increase surface area of zinc. Or I can simply say use powdered zinc. So either of these two will work for you. Use powdered zinc, increase the surface area of zinc, concentration, higher concentration of the acid. Now, Perry wants to measure the volume of a gas given. He wants to measure the volume of the gas given. Complete diagram of the equipment Perry used to collect and measure, okay, the volume. So what we are looking at here, okay, is very simple. Is how do I measure variables? Remember, if it is volume of a liquid, okay, volume of a liquid, I can use a measuring cylinder, a measuring cylinder, okay, a pipette or a pipette, okay. But here we are looking at the volume of a gas. So two things are possible here. Is either I'm using a syringe, which is the easiest one. So I can just draw a syringe, here, and have a plunger inside. Okay, so graduated syringe. Okay, you can draw more better than I do. Okay, so that's simply for a syringe. So I could use this. Okay, and I could also do a sketch of a delivery tube and have an inverted measuring cylinder. Okay, I have an inverted measuring cylinder. Okay, something like this. Inverted measuring cylinder. So, and then I have a tube. So if I'm not doing this, I could have something like this connected. So this is going to be in the beaker. So I inverted this inside. So that could be another way. So either I'm using a syringe or I use an inverted measuring cylinder, to get that. All right. So Perry does a risk assessment of his investigation. He decided to wear safety goggles. Why does he decide to wear safety goggles? Why? Okay. So majorly, let's take a look at what he's using. Okay. He's using an acid, okay, dilute hydrochloric acid and zinc. So our major hazard is going to be from the acid. So we can then say that if our major hazard is from the acid rather than the zinc, we can then say that to stop the acid from entering his eyes, to stop the acid from entering his eyes, to stop the acid from entering his eyes, being that acid is a major hazard from what he's working with. All right. Thank you for listening to this session. In our next video, we'll now be looking at progress grade paper for 2022. Stay tuned.